Welcome everyone. Problem based on divisibility rules is asked in aptitude test of companies like CTS, Wipro, Infosys, Mindtree, etc. Questions based on divisibility rules are really easy if we know the basics. So answering these questions correctly will help us boosting our cutoff mark easily. Now let's see some of the questions asked in placement papers of some companies. Find the largest 7-digit number which is completely divisible by 2, 3 and 5. They are asking for a 7-digit number. So option C cannot be an answer. We know that to check whether a number is divisible by 5, we have to see whether the last digit is either 0 or 5. So option A cannot be an answer. We know that to check whether a number is divisible by 2, the last digit must be an even number, that is 0, 2, 4, 6 or 8. So this number option B ends with 5 and so that cannot be an answer. To check whether a number is divisible by 3, we have to sum up the digits. As all the digits here are 9, definitely the sum will be divisible by 3. As it ends in 0, it will be divisible by 2 and 5. So this number is the answer. Check whether 5, 2, 6, 8, 9, 7 is exactly divisible by 7. We know that to check whether a number is divisible by 7, we will take the last digit out, double it and subtract it with the remaining. Let's do it for this number. 5, 2, 6, 8, 9, 7. We are going to take the last digit out and double it, which will be 14. When subtracting it with the remaining, we will get 5, 2, 6, 7, 5. To check whether 5, 2, 6, 7, 5 is divisible by 7, we will take the last digit out again, double it and subtract it with the remaining. So the number will be 5, 2, 5, 7. To check whether 5, 2, 5, 7 is divisible by 7, again we are taking the last digit out and doubling it and subtracting it with the remaining. We will get 5, 1, 1. To check whether 5, 1, 1 is divisible by 7, again we are going to take the last digit out, double it and subtract it with the remaining. 51 minus 2 will be 49. We know that 7 sevens are 49. So 49 is definitely divisible by 7, which makes this number 5, 2, 6, 8, 9, 7 to be divisible by 7. So the answer is option A, yes. What least value must be assigned to star so that the number 63576 star 2 is divisible by 8? We know that to check whether a number is divisible by 8, we have to see whether the last 3 digits are divisible by 8. To check whether the last 3 digits are divisible by 8, we will see whether the last 3 digits are divisible by 2 thrice, or we will take the last digit out and add it to the double of the remaining. Let's go from the options and substitute the value of star to be 1. So the number will be 612. To check whether the number 612 is divisible by 8, we will take the last digit out and add it to the double of the remaining, which is 61 into 2, 122. So 122 plus 2 will be 124. To check whether 124 is divisible by 8, again we will take the last digit out and add it to the double of the remaining. 12 into 2 will be 24. 24 plus the last digit 4 will be 28. We know that 28 is not divisible by 8. So option A cannot be an answer. Let's assume the value of star to be 2. So the number will be 622. To check whether 622 is divisible by 8, again we will follow the same process. We will take the last digit out and add it to the double of the remaining. So 62 into 2 will be 124. 124 plus 2 will be 126. To check whether 126 is divisible by 8, again we will take the last digit out and add it to the double of the remaining, which will be 24 plus 6 equal to 30. We know that 30 is not divisible by 8, so option B is not the answer. So let's assume the value of star to be 3. So the number will be 632. We will repeat the process again. Take the last digit out, add it to the double of the remaining. 63 into 2 will be 126. 126 plus the last digit 2 will be 128. To check whether 128 is divisible by 8, again we will take the last digit out and add it to the double of the remaining, which is 24. So 24 plus 8 will be 32. We know that 32 is divisible by 8. 8 fours are 32. So 32 is definitely divisible by 8, which makes this number 632 to be divisible by 8. So the answer is option C, 3. If the number 7x86038 is exactly divisible by 11, then the smallest whole number in place of x is, okay, we know that to find whether a number is divisible by 11, we will find the difference between the sum of the digits at odd places and the sum of the digits in even places. If the answer is 0 or any multiple of 11, then the number is said to be divisible by 11. Here the number is 7x86038. The sum of the digits in odd places will be 8 plus 0 plus 8 plus 7. 8 plus 0 plus 8 plus 7 will be 23. The sum of the digits in even places will be 3 plus 6 plus x. 3 plus 6 plus x will be 9 plus x. To find the difference between the sum of the digits in the odd places minus sum of the digits in even places, we will take 23 minus 9 plus x is equal to 0 or any multiple of 11. Here 23 minus 9 minus x will be 0 or any multiple of 11. So 14 minus x will be 0 or any multiple of 11. The nearest multiple of 11 to 14 is 11. So let's assume 14 minus x to be 11. So the value of x will be 3. So the answer is option C, 3. Let n is equal to 80pq2pq, which is a 7-digit number. If n is exactly divisible by 120, then the sum of the digits in n is equal to, okay, it is given that n is divisible by 120. So we have to check whether n is divisible by 4, 3 and 10. As n is divisible by 10, the last digit of n, which is q, must be equal to 0. When q is equal to 0, n becomes 80p0 2p0. It has to be divisible by 3. So the sum of the digits in n must be divisible by 3. 8 plus 0 plus p plus 0 plus 2 plus p plus 0 is equal to a number which is divisible by 3. Let's go from the options. Option A is 18. So 2p plus 10 is equal to 18. P is equal to 8. 2p is equal to 8 and p is equal to 4. When p is equal to 4, n becomes 8040240. To check whether n is divisible by 4, we will see whether the last two digits is divisible by 4. The last two digits is 40, which is divisible by 4. So this number 8040240 is divisible by 3, 10 and 4. So option A, 18 is correct. Find the remainder when 1201 into 1203 into 1205 into 1207 is divided by 6. Instead of finding the remainder for the whole product, we can first find the remainders of the individual numbers. The remainder of 1201 when divided by 6 is 1. The remainder when 1203 is divided by 6 is 3. The remainder when 1205 is divided by 6 is 5. The remainder when 1207 is divided by 6 is 1. When we multiply these remainders together, we get 1 into 3 into 5 into 1, which is equal to 15. When we divide 15 by 6, the remainder is 3. So the answer is option B, 3. The sum of 3 consecutive natural numbers, each divisible by 3, is 72. What is the largest among them? Let's consider a number divisible by 3 to be 3x. They are saying 3 consecutive numbers. So the number next to this, which is a multiple of 3, will be 3x plus 3. The number after this will be 3x plus 6. It is said their sum is 72. So 3x plus 3x plus 3 plus 3x plus 6 is equal to 72. 9x plus 9 is equal to 72. 9x is equal to 72 minus 9, which is equal to 63. X will be equal to 7. They are asking us to find the largest. The largest is 3x plus 6. When we substitute x to be 7, it will be 3 into 7 plus 6, which is equal to 21 plus 6 equal to 27. So the answer is option C, 27. In a division problem, the divisor is 20 times the quotient and 5 times the remainder. If remainder is 16, the number will be, it is said that the divisor is 20 times the quotient and 5 times the remainder. If remainder is equal to 16, they are asking for the number. We know that the number is equal to quotient times the divisor plus the remainder. It is said that the divisor is 20 times the quotient and 5 times the remainder. The remainder is 16. So divisor is equal to 5 into 16, which is equal to 80. We found the divisor to be 80. So the quotient is 80 divided by 20, which is equal to 4. So we know the value of the quotient, the divisor and the remainder. Now the number will be 4 into 80 plus 16, which is equal to 320 plus 16, which will be equal to 336. So the number is 336, which is option B. The difference between two numbers is 1365. When the larger number is divided by the smaller number, the quotient is 6 and the remainder is 15. The smaller number is, okay, they are saying that the difference between two numbers is 1365. Let's consider the two numbers to be A and B. A minus B is equal to 1365. When the larger number is divided by the smaller one. So here the larger number will be A. When it is divided by the smaller one, the quotient is 6 and the remainder is 15. So we can write A is equal to 6B plus 15. When we substitute A to be 6B plus 15 in this equation, we will get 6B plus 15 minus B is equal to 1365. 5B is equal to 1365 minus 15. 5B is equal to 1350. B will be equal to 270. So the smaller number is 270, which is option C. The least perfect square which is divisible by each of 25, 70 and 35 is, to check whether a number is divisible by 25, we have to check whether the last two digits are divisible by 25 or if the last two digits are 0. To check whether the last two digits are divisible by 25, we can see whether the number is divisible by 5 twice. To check whether a number is divisible by 70, we have to check whether the number is divisible by both 7 and 10. To check whether a number is divisible by 35, we have to check whether the number is divisible by both 7 and 5. It is said least perfect square. So we can go from the least number in the options 1331. The last digit is 1, which will not be divisible by 10 or 5. So D is not the answer. The next small number is 1600. The last two digits are 00, which makes it divisible by 25 and 5. But the number 16 will not be divisible by 7. So option B is not the answer. The next smaller number is 4900. The last two digits are 00, which makes it divisible by 25. The last digit is 0, which makes it divisible by 10. And the number before that is 49, which makes it divisible by 7. So this number is divisible by 70. The last digit is 0 and it is also divisible by 7. So it is divisible by 35. As this number 4900 is divisible by 25, 70 and 35 and it is also a perfect square, the answer is option C, 4900. Which digit should come in the place of star and hash if the number 62684 star hash is divisible by both 8 and 5? To check whether a number is divisible by 5, we have to see the last digit is 0 of 5. Here it cannot be 5 because it is divisible by 8. So, we can say the last digit is equal to 0. To check whether a number is divisible by 8, we will see whether the last 3 digits are divisible by 8. Here the last 3 digits are 4 star 0. Let's assume the value of star from the options. Option A is 4. So the number is 440. To check whether the number 440 is divisible by 8, we will take the last digit out and add it to the double of the remaining. 44 into 2 is equal to 88. 88 plus the last digit which is 0 gives 88. We know that 88 is divisible by 8. So the answer is option A, 4 and 0. How many of the following numbers are divisible by 132? To check whether a number is divisible by 132, we have to know the factors of 132. The factors of 132 are 4, 3 and 11. So if a number is divisible by 4, 3 and 11, then the number is said to be divisible by 132. Let's take the first number, 264. The last 2 digits are 64, which makes it divisible by 4. The summation of the digit is 12, which makes it divisible by 3. The sum of the digit in odd places is 4 plus 2, 6. Minus the sum of the digit in even places is 6 equal to 0, which makes it divisible by 11. As this number is divisible by 4, 3 and 11, this number is divisible by 132. The next number is 396. The last 2 digits are 96. So this number is divisible by 4. The summation of the digits is 18. So this number is divisible by 3. The sum of the digits in odd places is 9 minus the sum of the digit in even places is 9 equal to 0, which makes it divisible by 11. As this number is divisible by 4, 3 and 11, this number is divisible by 132. The next number is 462. The last 2 digit is 62, which is not divisible by 4. So this number is not divisible by 132. The next number is 792. The last 2 digit is 92, which is divisible by 4. The summation of the digit is 18, which makes it divisible by 3. The sum of the digit in odd places is 7 plus 2, 9. Minus the sum of the digit in even places is 9 equal to 0, which makes it divisible by 11. As this number is divisible by 4, 3 and 11, this number 792 is divisible by 132. The next digit is 968. The last 2 digit is 68, which makes it divisible by 4. The summation of the digit is 9 plus 6 plus 8, which is 23, which is not divisible by 3. So this number 968 is not divisible by 132. The next number is 2178. The last 2 digit is 78, which is not divisible by 4. So this number 2178 is not divisible by 132. The next number is 5184. If we take the sum of the digit in odd places, 4 plus 1 is 5, and the difference between the sum of the digit in even places is 8 plus 5, which is 13. So 13 minus 5 is equal to 8, which is not divisible by 11. So this number 5184 is not divisible by 132. The next number is 6336. The last 2 digit is 36, which makes it divisible by 4. The summation of the digit is 18, which makes it divisible by 3. The sum of the digit in odd places is 6 plus 3, 9. The sum of the digit in even places is 6 plus 3 equal to 9, which is 0. So this number is divisible by 11. As this number is divisible by 4, 3 and 11, this number is divisible by 132. There are 1, 2, 3, 4 numbers divisible by 132. So the answer is option C, 4. Which of the following number is completely divisible by 99? To check whether a number is divisible by 99, the number has to be divisible by both 9 and 11. Let's go from the options. 1, 1, 4, 3, 4, 5. The summation of the digit is 1 plus 1 plus 4 plus 3 plus 4 plus 5, which is equal to 18. So this number is divisible by 9. The sum of the digit in odd places is 5 plus 3 plus 1, which is equal to 9. The sum of the digit in even places is 4 plus 4 plus 1, which is equal to 9. 9 minus 9 is equal to 0, which makes it divisible by 11. As this number is divisible by both 9 and 11, option A is divisible by 99. A 3-digit number 483 is added to another 3-digit number 984 to give a 4-digit number 13B7, which is divisible by 11. Then A plus B is equal to, they are saying 483 plus 984 is equal to 13B7. To find the value of B, it is given it is divisible by 11. So, the sum of the digit in odd places is 7 plus 3 minus the sum of the digit in even places is B plus 1. We can assume the value to be 0. So, 10 minus B minus 1 is equal to 0. So, B is equal to 9. Let's substitute the value of B to be 9 in this. So 483 plus 984 is equal to 1397. 3 plus 4 is 7, 9 plus 4 is 13. So A plus 8 is equal to 9. A is equal to 1. They are asking for A plus B. So A plus B is equal to 1 plus 9, which is equal to 10. The answer is option A, 10. Thanks for watching.